This video is for multiplying and dividing rational expressions. So when you're multiplying and dividing rational expressions, you have to remember, how do we multiply fractions? And a lot of you guys probably remember we focus on top times top and then bottom times bottom, and then we look to simplify the fractions. Okay, so we find that common factor. So we're going to take that idea now and apply it to multiplying rational expressions. All right, but now our process changes just slightly. So the first thing we're going to do, just like simplifying, we're going to factor. Factor what? Factor anything you can. You do that by GCF factoring, you do that by goal number factoring, whatever the case may be. Then what we're going to do is, to get that top times top over bottom times bottom, we're going to write as a single fraction all of our pieces from the tops and all of our pieces from the bottoms. We're then looking for common factors, and we're going to look to simplify it. So if I take this first example right here, 9x over 10 times 8x over 10, I'm going to rewrite this as 72x squared over 10 times 10, which will be 100. Now I look at these two terms and I recognize, oh wait, 72 and 100 both have some common factors. So I'm going to start off by saying, let's see, I think that 72 and 10, since they're both even, I'm going to write it as 2 times 36 times x squared. And 100, I want to write with a common factor of 2 and 50. All right, that will eliminate my 2's. But I still have a 36 and a 50, so let me try to reduce them further. I know 36 is 2 times 18, and then we still have the x squared on top. I know that 50 is really 2 times 25, all right, which will tell me that these 2's will cancel out again. How about 18 and 25? Well, let's see, the factors of 18, we got 2, 3, 6, and 25 will be 5 and 5, so I'm not seeing anything else. I'm ready to write my final answer, which would be 18x squared over 25. And that's my final answer in simplest form. So what happens if they give me polynomials? Well, we take the same approach. I look at the first numerator. I notice that 3x minus 3 has a greatest common factor, a GCF of 3. So I write that as 3 times x minus 1. I look at the first denominator, x plus 10. Can't factor that any further. I look at the second numerator, x plus 10. Can't factor that any further. I look at the next denominator and I notice goal number factoring. So our goal number is -9, middle term is 8, factors would be 9 and -1, and divide by a, which means divide them both by 1. So its factors are going to be x plus 9 and x minus 1. So I've got all these factors all over the place. What do I want to do now? I want to put everything together. So I'm going to start with the top. I know the multiplication of fractions is top times top. So I'm going to rewrite this as 3, the binomial x minus 1, and the binomial x plus 10. In the denominator, I'm going to go straight across. I have x plus 10, I have x plus 9, and I have x minus 1 as my 3 binomial factors. Now look to cancel. I have a monomial of 3. There's no monomials on the bottom, so 3 is not going to cancel with anything. X minus 1 will cancel with x minus 1. X plus 10 will cancel with x plus 10, leaving me with a final answer of 3 over x plus 9. And this is my final answer. Now, as we've always been saying, if I want to leave that in parentheses, that's fine too. So how about division? Well, in division, when you learn it in grade school, they probably taught you the idea of keep, switch, flip. Keep the first fraction, change the division to multiplication, and do the reciprocal or flip the second fraction. So we're going to still use this same idea to help us in doing these. So how do I divide rational expressions? Step one, factor anything you can, whether it's GCF or goal number factoring, just like we did for multiplication. But step two, when we write that single fraction, we got to be careful. So remember that the second fraction is flipped when we're dividing. So what does that mean? Well, we'll see in just a minute. And then we're going to cancel common factors. All right. So the first example I have here, I gave everything to us in factored form. So if it's factored form, I know to divide, I want to write a single fraction. My single fraction is going to have the first numerator, x plus 6, but the second fraction gets flipped. So everything on the bottom now comes to the top, x minus 10 and x plus 9. The denominator is going to start with the first denominator, 9 and x plus 6, and then the second numerator, the x plus 9 on top, is going to come down to the bottom. All right, that is the division algorithm. All right, keep the first, switch the sign from division to multiplication, flip the second fraction. All right, so I've got a single fraction now. I'm going to start with x plus 6. Cancels with the x plus 6 on the bottom. X minus 10 doesn't have anybody to cancel with. X plus 9 can cancel with x plus 9. On the bottom, I don't have anything going on with 9, and there's no monomial on top, so I can't cancel the 9 out. That tells me my final answer will be x minus 10 over 9. All right, and this last one, I tried to make it a little bit more challenging. Let's take a look here. So I notice it's division. I'm thinking keep, switch, flip, but I got a bunch of factoring to do. So let's start on the top part here. Goal number is positive 3. Middle term is negative 4. I know this will factor to x minus 3 and x minus 1. On the bottom, I have a GCF. So this will factor to 3 times x minus 8. In the second numerator, I have x minus 8 and x minus 1. I did goal number factoring on that. Goal number of 8, middle term of negative 9. On the bottom, I don't have to factor that. So now what I want to do is write this all as a single fraction. I'm going to drop down here. Here's my fraction bar. I have the first numerator, x minus 3 and x minus 1. I have the second fraction's denominator comes up because it's division, and that's x minus 8. I go to the first denominator, 3 and x minus 8, and I take the second numerator and flip it down. So that's going to be x minus 8 and x minus 1. I start on top and look to see what I can cancel. X minus 3, got nothing on the bottom. X minus 1, I got one on the bottom, cancel them out. X minus 8, I've got one on top and 2 on the bottom, but I can only cancel one of them. So what's left? Well, in the numerator, I've got x minus 3, and in the denominator, I've got 3 times x minus 8. And this is the simplified form of the division. Hope this helps.